Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, we're diving into the transformative power of API management and API gateway. Why is this so exciting? Because it's making your work with APIs smarter, not harder. In this unit, I will explain how API gateways can help manage calls to your APIs using policies and how you secure access to APIs by using subscriptions and certificates. In the digital age, APIs are the building blocks of innovation. They allow different software systems to communicate, share data, and function together seamlessly. As an Azure developer, you are either a consumer or a creator of APIs, or both. If you create and maintain APIs, then your organization might look for a way of publishing the APIs to external developers. API management and API gateway are tools that help you control this process, ensuring security, performance, and scalability. They can be the difference between a good software solution and a great one. Imagine you are running a global e-commerce business. Your website is your storefront. Inventory and sales team all rolled into one. Behind the scenes, you're using multiple software systems. Inventory management, payment processing, customer relationship management, and more. Each of these systems has its own API. Without proper API management, these systems might not communicate efficiently. This could lead to slow performance, security vulnerabilities, or even system failures. But with API management and API gateway, you can ensure that all your systems work together smoothly and securely. You can monitor API usage, control who has access, bundle APIs together as one product, and even manage how much traffic goes to each API. So join us as we explore how API management and API gateway can revolutionize the way you work and bring your software solutions to the next level. Let's break down the key components of this system. First up, we have the API gateway, the gatekeeper that ensures smooth and secure data flow between your APIs and their clients. It accepts API calls and routes them to your backends. It verifies API keys, JWT tokens, certificates, and other credentials. And it helps to transform your API's responses on the fly. More on that later in this video. Next, we have the Azure portal, your command center for managing and monitoring your Azure resources. And last but not least, we have the developer portal, a dedicated space for all developers, internal and external, to learn, explore, and test your APIs. Together, these components form the backbone of a successful API program in the enterprise landscape. What are products in the context of API management? These are packages of APIs that you present to your developers. Each product contains one or more APIs and comes with a title, description, and terms of use. Products can be either open or protected, with the latter requiring a subscription. The subscription approval process can be set to require administrator approval or be auto-approved. Groups are used to manage the visibility of products to developers. There are three built-in system groups: administrators, developers, and guests. Administrators manage the API management service instances, and developers are authenticated users who build applications using your APIs. And guests are unauthenticated users who can view APIs but not call them. Custom groups can also be created, and external groups from associated Entra ID tenants can be leveraged. Developers are these user accounts in an API management service instance. Developers can be created or invited by administrators, or they can sign up from the developer portal. Each developer belongs to one or more groups and can subscribe to the products visible to those groups. We have policies. These are a set of capabilities that allow you to change the behavior of the API through configuration. Policies are a collection of statements executed sequentially on a request or response of an API. They can perform various functions such as format conversion from, let's say, XML to JSON or call rate limiting. The developer portal is where developers can learn about your APIs, view and call operations, and subscribe to products. Prospective customers can also visit the developer portal, view APIs and operations, and sign up. The URL for your developer portal is located on the dashboard in the Azure portal for your API management service instance. The API gateway primarily acts as a reverse proxy, efficiently routing requests from clients to the appropriate services. It's the gatekeeper, ensuring that all incoming traffic is directed correctly and efficiently. But that's not all. The API gateway also applies various policies and collects telemetry data. This means it enforces rules on how your APIs are used and gathers valuable information on API usage. This information can provide insights into performance, help identify potential issues, and inform decisions about scaling and improvement. The API gateway is also equipped to perform a variety of tasks such as authentication, SSL termination, and rate limiting. Authentication ensures that only authorized users can access your APIs. SSL termination helps in offloading the SSL protocol processing to the API gateway, freeing up resources on the backend servers. Rate limiting is used to control the number of requests a client can send to an API within a specific time frame, protecting your APIs from being overwhelmed by too many requests. Let's think about what could go wrong when not using APIM. Deploying an API without a gateway can lead to several challenges. Clients have to manage multiple endpoints and handle failures, which can complicate maintenance and service refactoring. Operations involving multiple services can add latency due to numerous network round trips. Each service must individually handle authentication, SSL, and rate limiting. The need to expose client-friendly protocols like HTTP or WebSocket can limit protocol choices. Lastly, public-facing services increase the potential attack surface and require additional security measures. In this unit, we looked at the components and the functions of the API management service. Now in the next unit, we will look at securing your APIs. Your brilliant APIs are serving other departments in your organization well, helping them to create powerful, dynamic applications. You're now tasked with making these APIs available also to external developers. This is where you need to learn about Azure API management security features to prevent unauthorized access, protect sensitive data, and maintain the integrity of your services. In essence, it's about building trust in your applications and in turn, your brand. To secure your APIs and track their usage, you will implement security policies and certificates as a start. In this unit, we will talk about how to secure access to the APIs by using subscriptions and certificates. With policies, you change the behavior of the API. Policies are configured as an XML document that outlines a series of statements for inbound and outbound traffic. These statements define the rules and behavior for processing API requests and responses. On the right-hand side, we have an empty policy configuration that is divided into 4 sections: inbound, backend, outbound, and error. The inbound section contains statements that are applied to a request as it arrives at the API gateway, but before it is routed to the backend service. The backend section contains statements that are applied to a request after it has been authorized, but before it is sent to the backend service. The outbound section contains statements that are applied to a response from the backend service before it is returned to the client. And the error section contains statements that are executed when an error occurs during the processing of the request. I want to show you two simple policy examples. The example on the left-hand side is a snippet of a policy that restricts a single client IP address to only 10 calls every minute. On the right-hand side, we have two different policies applied. For inbound traffic, cross-domain calls are allowed, and in the outbound section, this policy finds the response substring XYZ and replaces it with ABC. Now you probably have noticed that both inbound sections have the base element added. What is that? The base element inherits the policies configured in that section at the parent scope. On the left, the base element is added above the rate limit by key policy, which means that all parent policies will be applied before the rate limit. On the right, cross-domain will execute before any higher policies. If we would add any further inbound policy to this section, they would be executed after the parent policies. In the outbound section, we have the policy that finds and replaces a substring. Since the base element is missing in this section, parent policies are not applied at all. However, the base element is included by default in each policy section. For these examples, we have deliberately removed it. You can go beyond these simple examples and unleash the full potential of your APIs with API Management Advanced policies. Tailor your API behavior with powerful control flow policies. Limit concurrency, log to an event hubs for further processing, and more. This is just a selection of advanced policies. You will find the full list at Microsoft Learn. Let me show you a few of these examples in their XML form. The limit concurrency policy prevents enclosed policies from executing by more than the specified number of requests at any time. When that number is exceeded, new requests will fail immediately with the 429 too many request status code. The key can be a request context variable, for example, connection ID. The forward request policy forwards the incoming request to the backend service specified in the request context. The amount of time in seconds to wait for the HTTP response headers to be returned by the backend service before a timeout error is raised. Follow redirect specifies whether redirects from the backend service are followed by the gateway or returned to the caller. And the log to event hub policy sends messages in the specified format to an event hub defined by a logger entity. As its name implies, the policy is used for saving selected requests or response context information for online or offline analysis. You have just published your APIs through Azure's API Management. Now you want to secure access to those APIs. How do you do that? First, you use subscription keys. Second, you use an additional method of authentication or authorization like OAuth or client certificates. But first things first, in the context of APIM, what's a subscription key? Well, to access APIs, you need a subscription. And a subscription can be scoped to all APIs an API gateway offers, a single API, or a product, which as we know is a bundle of several APIs. A subscription is essentially a named container for a pair of subscription keys. These keys are your ticket to secure API access. Like in other services that are protected by keys, you have always a primary and a secondary, and you can regenerate them at any time. In case one got exposed or you just want to be on the safe side. And how do you use these subscriptions? It's easy. You can pass them through in the headers of your client request, or even as a query string parameter. The default header name is OCP APIM subscription key as shown on the slide. I already hinted earlier that a subscription key is not a strong form of authentication by itself. One of the ways to enhance security is by client certificates. Picture this. You've got a client and an API gateway. You want to ensure mutual authentication between the two. How do you do that? The answer lies in Transport Layer Security, or TLS. By using certificates, you can provide TLS mutual authentication, creating a secure communication channel. But we are not stopping there. You can take it a step further by configuring your API management gateway to only allow requests with certificates containing a specific thumbprint, subject or issuer. This adds an extra layer of security, ensuring that only authorized requests get through. And how is this authorization handled? Through inbound policies at the gateway level. In other words, we configure a control flow policy that checks, like in this example, if we have a valid certificate in the request context. If there's no certificate information at all, or the issuer is not the trusted one, or the subject name is not what we expect, then we let the gateway return a 403 code stating invalid client certificate. In the next demo, I will show you how to apply policies to an API in API management. In this video, I will show you how to apply policies to an existing API management gateway instance. I have already an API management instance in the developer tier deployed. So if I open this up, I can show you that I have imported a demo API already. That is an external API that is provided by someone else. I'm not running the backend behind this, and I'm going to explain what it does. So if I click here in this configuration overview, I click the demo conference API, and this API consists out of different operations. So the idea here is that we have a data set that gets us either a list or specific sessions, speakers, or a list of all the speakers for that conference. And all the different operations are sent to a specific endpoint. And this endpoint is configured here as this, obviously it's an Azure web app that is, as I said, it's run by someone else. I'm not in charge of this one, but that reports back with the information. So how does that look like? So what can I do in here? First of all, let's get a list of all speakers. So if I click one of those operations here, I can see a bit more information about the individual operation. And if I would like to test this and to see what it returns, I can go ahead and click on test. If I want, I can add parameters, but it's not necessary. All of these are optional. And if I scroll down, it tells me here, this is exactly the request that it will send. And this is the get operation, just to get the speakers back. So let's do this. Let's send this off and see what the response will get back. I will scroll down a bit. So first of all, it worked. So I get a 200 status code, it's all okay. I get the different information, different headers. That is the kind of data that I'm seeing here. It's an older conference, but you can tell that this is coming from that endpoint. That is not the same endpoint that I'm looking for or that I'm managing with my API management instance, but that is provided by someone else. And here I see a list of the different speakers, just some text about it in JSON format. So if you look at this, I would say from a security perspective, I see a couple of things that are concerning. First of all, to expose that kind of information, which is enabled by default, would potentially give an attacker some ideas how to best attack. I don't need this in the response for my consuming applications to work properly. They're probably not expecting this. So this is something I would like to somehow remove from here. Also, I'm not really keen on that fact that it shows here that there's an API, an external API used for my endpoint. What does the customer think that works with this API that I provide? They can just run that API right away. And if it gets the information back as well, they can just avoid using my services. So I want to fix this. And I will do this with designing some policies or adding some policies. Now for that API, I can either apply a policy for a specific operation like the get speakers one or to all. I will decide to do this now for all because the things that I have pointed out, they're affecting all the operations. It doesn't matter if it's getting sessions or getting speakers or anything else. Now in the configuration here, you can tell that I can apply inbound policies and outbound policies, and I will do this right now. So one thing that I would like to start with is let's get rid of these headers. So I will use the UI right now. By using that UI, and I will show you this later, there's just an XML file configured in the backend. So you can do this on a text base, or you can do this using the UI. So I will use the UI first. So first of all, I know that was the xasp.net version that I would like to get rid of, and the other one was the powered by. So what I want is not to override this or append something else. I would like to get rid of this. And in here, I will just skip this for the deletion and then go and save. Okay, it says here that those headers that are marked for deletion cannot have any value specified. Yeah, the UI is not really super intuitive here, but what that actually means that I should check. Yeah, there's actually for some reason here an empty value added. So if I just remove this, I should be able to save it now. I have two different set header policies added to this. Another thing that I would like to use is let me show you the XML version of this, because I want to add another one that is not part of the UI. I need them to go to the documentation and look it up, but I can memorize it. It's easy enough. So this is what the XML file looks like, and we saw some examples earlier on the slide. I have now configured outbound policy, and I would like to add another one that is called redirect. The redirect content URLs, it has some sort of IntelliSense in here, so I just have to remember what it starts with, and I will show you what that means. So it's very easy to work with this. Now I have all these different things, and let's do one more thing. I would like also to limit. Let me see. Oh yeah, there's a double angular bracket here, so we don't want to do this. I want to add also one inbound policy to show you what you can do in here. So let's see. Let's check the options. I can filter IP addresses, limit calls, configure macro responses. What I would like to do here is now limit the amount of times that this API can be called, or any operations of that API can be called. Let's configure rate limit. Let's say I want this not to be used more often than 3 times within 15 seconds. Based on the API subscription, could also be the IP address. That's just it. And let's see what happens when I configure that that way. Now I've applied this policy. I'll go back to this get speakers operation, and let's try it again. So we'll do the same thing as before. We'll send it, wait for the response. Now that I have the response, looks good, okay. Yeah, see here, the 2 headers that I was concerned about before are gone. And the next thing is what I did with this inbound policy is now, or actually no, it was not the inbound policy, it's still an outbound policy. I said redirect the content URLs. And what that did is, look here, it looks like this is actually coming from my API gateway. It's using this URL for my managed service, not the external anymore. It's replacing the content URLs with its own. So that looks much better. Now, what about the inbound policy that I've created? Let's try to run this once, twice, 3 times, and 4th. And now I get an error message. It says here too many requests. It also tells me, yeah, by the way, you can try again in 6 seconds, and also gives me this in clear text here. So that was more than 6 seconds. So let's just do it again. And it should be coming back with a 200 again. Yeah, so that is my inbound policy. This is a super helpful way to control how your APIs are used, what kind of information you're exposing, and it's very easy to apply this with that kind of policy configuration. Now in this video, I explained how API gateways can help manage calls to your APIs and how to secure access to APIs by using subscriptions and certificates. Congratulations on mastering Azure API Management and its functionalities for transforming and securing APIs. By learning how to create a backend API and implement security measures, you are ready to optimize your API ecosystem for enhanced performance and reliability. With Azure API Management, go and streamline API management processes and unlock new opportunities for API monetization and innovation. Thanks for watching. Keep on learning.